a straight line, but it may not be necessary that the straight line have to touch all the parts. In some cases it's not necessary. So if you are drawing a straight line in a graph, sometimes it does not touch all the points. So we proceed with our graph work. Now from here, the first step, draw the y-axis vertical and x-axis horizontal. And the first thing we should do is to draw. You have to use a pencil, but for the sake of the video I may use pen so that it can be visible to the audience. So here I'll use a pencil first, then later I flow it with a pen. So I rule a line here, straight line. That's the vertical axis. Another line here. I want to use a pen for clarity so that you can recognize it. You are advised to use a pencil in graph. Take note of that so that you can recognize it. That's why I'm using this. So here is our y-axis and the x-axis, but here instead of using the x-axis I'll use voltmeter reading, because coming back to the question, using the figures in the table, plot a graph of V on the vertical axis. That is, in the vertical axis we have what? Voltmeter reading, and the unit we have what? Voltmeter reading here. The unit is volt. In volt, make sure you leave a space so that the figures can fit here. And I on the horizontal axis, which is the current. So I is for current. We write current in ampere. So from here we have to did the second one. The third one, choose a simple scale from the figures that are given in the table. So when you are choosing your scale, you have to be very much careful. So I can also, when I choose my scale, I can write it here for better understanding. Voltmeter reading. When it comes to the voltmeter reading, you look at the highest number before you choose your scale. The lower number and the highest number is very vital. So here we have 1.0. Yes, if we are to choose our scale here, and we says probably 1 centimeter or 10 unit, we know that that will not work because the highest number here is 10. So we take note, by looking at this we cannot use that. So we use what? Smaller numbers, because we have 1 here. So if I told this starting here is 10, probably then we can say 1 centimeter 10 unit, or so on and so forth. But here, since we have the highest number, we have to use smaller numbers in choosing our scale. You need to take note of that. So here In this side, you can see in the voltmeter side, we say what 2 centimeter to 1 unit. Voltmeter reading 2 centimeter to 1 unit. Let me just write it here. Voltmeter reading. The scale, I can put it on top. The voltmeter reading. We use what? We use 2 centimeter 1 unit. 2 cm to 1 unit. You should also check whether when you use it, it will able to fit here. You take note of that. Due to time, I am rushing, so you take note. If I put 2 centimeter 2 unit, you calculate whether you will have the highest number here, 10, whether it will fit. So those things need to be noted. So on the ammeter reading, I can, from the question you have seen in decimals, so I have to use smaller numbers in decimals since we have them in decimals. So you take note of that. You have lower numbers using the scale, you have to be very much careful. So here on the ammeter reading, I can say 1 centimeter to 0.1 is the same as 0 units. So now I have to use the scale I've chosen to put the number. So 2 centimeter from here to here is 1 centimeter, 2 centimeter to 1 unit. So here, since you have them in decimals, I can just put it in decimal. Say 2 centimeter to 1 point here, 1.0, 1.0, 2 centimeter to 1 unit plus another one will give us 2.0. Then we have this 2.0. Then we have 3.0, 2 centimeter to 1 unit. Take note of it. 2 centimeter to 1 unit, 3.0, 4.0. Then we have this 5.0, 6.0, 7.0. And we have this 8.0, 9.0, 10.0, and 11.0. You see, the highest number is 10.1. So stopping here is still okay. Then from there, the scale I have chosen here is 1 centimeter, 0.1. 0 is all the same, 1 centimeter. So here 1 centimeter to 0.10. So here is 1 centimeter. I'll have what? 0.10. Here I'll have 1 centimeter. I have 0.20. The next one 0.30, 0.40, 0.50, 0.60, 0.70, 0.80, 0.90. Then when you have this, you will have 1. Take note of it. When you add this, like you have 0.9 plus 0.1. You see what we have? 1. So you take note of it. It should be 1 0.00. If you want, you add another one, that is 1.10, then 1.20, 1.30, 1.40, and when you look at this, in fact the numbers isn't right after that. So here 1.40, here we have 1. So if you want, we even stop there, because we have up to 1.95. so here, sorry, 0.95. The highest, I presume, from the table. Yes, this seem to be okay. Even if we stop here, now from here, now we use this and plot our graph. Now before you plot it, try to know each line is giving you which figure. It's very significant that you know it. Here we have the first number here is 1, so we can say 1 divided by 10, because the total number of line is 10. So it simply means each line is 0.1. So each line is 0.1 in the vertical axis. We take note of that. It's very significant. On vertical, each line equals to 0.1. Horizontal, we can also know horizontal line, or we have it as the first number 0.1. So 0.1, others we have 5 lines. We can divide it. 0.1 divided by 0.1 divided by 5 simply mean each line is giving us 0.02. So we have to take note of this as we plot the graph. This will guide us. So here you plot the coordinate that are given. You need to know how to plot this now. Yes, at the voltmeter reading we have 1.0. We look at where we have 1.0 is here, and ammeter reading we have 0.17. Yes, we look at it. Where do we have 0.17? We have 0.1 here. Each line is giving us 2. So here 0.02. So here we have in the voltmeter we have 1.0, that is here voltmeter reading. Here we have 0.17. So here is 1. So each line is giving us 0.2. We keep on adding on 0.2. As we move on, we see the first line 0.1 plus 0 0.02, you have 0.12.